Welcome to the Menasco Training and Mentoring Center. We are pleased to have an opportunity to share our knowledge and know that you will be learning from some of the finest engineers anywhere. Remember, learn more, earn more. Now let's get started.
This session focuses on the correct installation of DB backboxes, which are critical for housing distribution boards safely and securely. The goal is to ensure that all installations comply with safety regulations, project specifications, and electrical codes. Throughout the class, we will cover the entire process, from preparation and approvals to installation, quality checks, and handover. Engineers will understand not only the technical aspects, but also the inspection and supervision responsibilities. For mid- and senior-level engineers, this knowledge ensures that backboxes are properly aligned, firmly fixed, and compliant with standards, which directly impacts the reliability and safety of the electrical system. A DB backbox is essentially a steel enclosure embedded in a wall or mounted on a surface, designed to house distribution boards. These boxes can be flush-mounted, meaning recessed into the blockwork, or surface-mounted where recessing is not feasible. Their primary purpose is to provide a protective, fire-resistant housing for breakers, bus bars, and wiring. When installed correctly, they ensure safe access for maintenance, achieve a neat and level finish with the wall surface, and guarantee long-term reliability of the electrical distribution system. Improper installation, on the other hand, could compromise fire safety, hinder accessibility, or result in alignment issues that complicate future maintenance. The DB backbox system is made up of several integrated parts. The backbox itself is the steel enclosure that holds everything. Inside, the assembly contains bus bars, mounting rails, breakers, and terminals, the functional core of the electrical distribution board. The front cover or door provides a secure, lockable finish, often labeled for easy identification. Cable entry points, such as knockouts or gland plates, allow conduits and cables to be connected neatly and securely. Finally, earthing bars and fixings ensure safe grounding and structural stability. Each component must be installed properly to provide a system that is not only functional, but also safe and compliant with regulations. To install a DB backbox correctly, a wide range of tools and materials is required. Essential tools include drills, screwdrivers, pliers, spanners, measuring tapes, and spirit levels, all used to ensure precision and alignment. For heavy units, lifting aids such as forklifts or chain hoists may be necessary, along with scaffolding or ladders to access elevated positions. Approved DB boxes, anchors, concrete, and screws are the main installation materials, while thermocol or protective board covers are used to protect the box interior during plastering works. Equally important are PPE items such as helmets, gloves, high-vis vests, and dust masks, ensuring worker safety at all times. Finally, calibrated test instruments like multimeters and continuity testers are indispensable for verifying electrical integrity once installation is complete. Before beginning installation, it is essential to confirm that shop drawings, method statements, and risk assessments have been reviewed and approved. Necessary permits must be obtained, especially for working at height, drilling, or hot works. Engineers should inspect wall openings to confirm they are correctly sized and positioned. Materials must be verified against submittals through material inspection requests to ensure the correct box is being used in the right location. Coordination with civil teams is also critical, particularly for recesses, supports, and finishing requirements. Finally, a toolbox talk and safety briefing should be conducted with the crew to align everyone on risks and responsibilities before work begins. The installation process starts with careful marking of the DB location, confirming its height above finished floor level, and ensuring alignment using a spirit level. The backbox is then positioned in the opening or on the surface, making sure orientation is correct. Temporary fixing is done first, using wedges or struts to hold the box in place. Permanent fixing differs depending on type. Flush-mounted boxes are grouted or concreted in place, while surface-mounted boxes are secured with drilled anchors. Once fixed, the opening is protected with foam or board covers to keep the interior clean. An alignment check follows, confirming the box is level and flush with the wall. Finally, the grout must be allowed to cure, with the box kept protected during plastering and finishing works. Safety is paramount throughout the process. Workers must always use PPE, including helmets, gloves, shoes, and harnesses where required. Only certified scaffolding and safe lifting gear should be used, and lockout, tag-out procedures must be followed near live electrical sources. The site must be kept tidy, with unsafe areas barricaded. From a quality assurance perspective, only approved materials should be used, and installations must strictly follow construction drawings and manufacturer's guidelines. Alignment, leveling, and fixing torque should be checked, with inspections conducted at defined hold points before the installation is concealed. Documentation with checklists, photographs, and inspector sign-offs ensures compliance and accountability. After installation, testing and inspection are mandatory. A work inspection request, WIR, is raised for QA/QC and consultant review. Inspectors will check the location, alignment, and level of the back box, as well as how securely it is fixed. The flushness of the box with the wall finish is also verified. Cable entry points must align correctly, and the presence of an earthing bar is confirmed. Once physically secured, electrical checks like continuity and earth bonding tests are performed to verify grounding. All results are recorded with checklists, photographs, and inspector sign-offs, forming the quality trail for the project. Once testing is complete, any outstanding defects or snags must be corrected, and the work re-inspected. As-built drawings are updated to reflect the actual DB locations, dimensions, and details. Quality control documentation, including MIRs, WIRs, torques logs, and photographs, is compiled. Operation and maintenance manuals are prepared, containing data sheets, maintenance routines, and warranty information. The final step is formal handover, where the installation is presented to the client or consultant along with training if necessary. This ensures the system is fully accepted and ready for long-term operation. DB backbox installation must conform to multiple codes and standards. Project specifications define the type, size, fire rating, and installation method for the backbox. Local regulations such as DEWA or other authority rules specify minimum clearances, access requirements, and mounting heights. International standards like IEC 61439, low voltage assemblies, BS 7671, wiring regulations, and NEC/NFPA codes provide guidance on safe electrical installations. In addition, manufacturers' guidelines must always be followed for product-specific instructions. Adherence to these standards ensures installations are safe, compliant, and maintainable. In conclusion, DB backbox installation is a critical step in ensuring safe and reliable power distribution. A structured, methodical approach guarantees compliance with codes, safety during installation, and long-term quality of the system. Proper alignment, fixing, and protection during construction prevent future issues such as misaligned boards or compromised fire safety. QA/QC processes, along with collaboration with civil and MEP teams, ensure smooth approval and handover. Ultimately, a well-installed DB backbox delivers long-term performance, reduces maintenance risks, and ensures client satisfaction. Please pause this video when the next slide appears, and you might want to take a picture of the associated QR codes so you can take the quiz and watch the supplemental video. To wrap up this session, we provide two important resources. The first QR code links to a quiz designed to test your understanding of today's session. This will help you evaluate your grasp of both the theoretical and practical aspects of DB backbox installation. The second QR code provides access to an on-site training video where you can see real-life installation practices demonstrated step by step. Watching this video will reinforce what we discussed today and help connect theory with practice. I encourage all participants to complete both activities, the quiz to check your knowledge and the video to observe practical applications in a project environment.